Hello students. Now we are going to discuss very important topic, that is preparation and properties of compounds of noble gases. Already you know, we have read in last class that noble gas are chemically inert. Generally they do not form compounds because due to their stable electronic configuration. That's why they are chemically inert. That's why they are called noble gases or inert gases. But they can react with the elements which has high electronegativity character, because noble gases generally they have very less tendency to donate electrons. So the elements like oxygen and fluorine can combine with noble gases, form oxides and fluorides. That's why as the xenon is the more reactive noble gases due to low ionization energy, that's why it produces only oxides and fluorides, because due to more electronegativity of oxygen and fluorine. So let us discuss some preparation and the properties of noble gases. Just to see, xenon generally produce fluorides and oxides. Mainly three types of fluorides exist of xenon: xenon difluorides, xenon tetrafluorides, xenon hexafluorides. And also xenon produce xenon oxides, trioxides, and it also produce xenon oxyfluorides. Like this, different types of compounds of xenon available, because it produce mainly compound with oxygen and xenon, oxygen and fluorine due to more electronegativity of oxygen and fluorine. Here you see, xenon when combined with fluorine at a high temperature about 673 K and 1 bar pressure, it produces xenon difluorides. You have to remember the temperature and pressure so that it will be better for your different competitive examination. Similarly, xenon when combines with fluorine at a higher temperature, that is about 873 K, and just more pressure, that is 7 bar, then it produces xenon tetrafluorides. But a condition is must necessary. High temperature and pressure also required for the formation of fluorides of xenon. So high temperature and more pressure then produce xenon tetrafluorides. Similarly, more fluorine can combine if the pressure is 60 bar or between 60 to 70 bar pressure. Then temperature is 500. When the pressure is very high, then temperature can be low. Temperature is 573 K, then pressure is 60 bar. It produces xenon hexafluoride. So difluorides, tetrafluorides and hexafluoride produced from xenon and fluorine under different condition of temperature and pressure. Then you see, these fluorides of xenon are very unstable and it react with water and easily hydrolyze with water. When it undergo hydrolysis, it produce different compounds and elements. Xenon difluoride when combined with water, when undergo hydrolysis, produce xenon and hydrofluorides and oxygen. You see, these three things are produced. Xenon and hydrofluorides and oxygen, both produced when xenon difluoride undergo hydrolysis. This is complete hydrolysis. Similarly, when xenon tetrafluorides undergo hydrolysis, produce xenon trioxide, HF and oxygen. You see, in both cases HF is produced. Why? Because fluorine is more reactive towards hydrogen. Because fluorine has more affinity towards hydrogen. That's why it produces HF molecule. First case HF, second case HF, always produce HF because fluorine has more affinity towards hydrogen. That's why HF is produced and remaining oxygen. Similarly, tetrafluoride produce xenon trioxides, HF and oxygen. So you have to remember this is you see four products are produced. Four products produced from xenon tetrafluorides. Xenon is the common, you see, and here trioxides and HF is also common and oxygen is also produced. Main difference is here xenon trioxide is produced, and this xenon trioxide is mild explosive. Mild means it is also unstable because xenon has very little tendency to form compounds. That's why all compounds of xenon generally unstable. That's why xenon trioxide is explosive, mild explosive. So when xenon hexafluoride undergo hydrolysis, it produces xenon trioxide and HF, and this trioxide is mild explosive. This is the this product of hydrolysis, this is the complete hydrolysis. All that is when complete hydrolysis takes place, that much of water is required for hydrolysis is taken. So difluoride produce HF, oxygen and xenon, tetrafluoride produce xenon, HF. These three are common for first, but xenon trioxide is new product. But when hexafluoride undergo hydrolysis, produce only xenon trioxide and HF. So you remember the difference between hydrolysis of fluorides of xenon. Then you see when the fluorides of xenon undergo partial hydrolysis, when you control the hydrolysis, you see the product. For partial hydrolysis of xenon hexafluoride with water, you produce xenon oxytetrafluorides. XCOF4 is produced. Very important. It will be asked in your computed examination. You see the difference. When you will take one water molecule, it will produce xenon oxytetrafluorides. When you take two water molecules, if it takes two water molecules, when it takes two water molecules, then it will produce xenon dioxydifluorides. Xenon dioxydifluorides. So this is the difference between xenon hexafluoride water taking one water molecule, then xenon hexafluoride taking two water molecule. If it will take three water molecule, the product is this one. When it takes three water molecule, the product is xenon trioxide. But when it takes one water molecule, it produces xenon oxytetrafluorides. When it takes two water molecule, it will produce xenon dioxydifluorides. So you see the difference between xenon product of hydrolysis of xenon hexafluoride in different water molecule, partial hydrolysis. Then another important property of fluorides of xenon is it acts as a fluorinating agent. Fluorinating agent. Which acts as a fluorinating agent? This one. All fluorides of xenon acts as a fluorinating agent. Fluorinating agent provides fluorine. So it acts as a fluoride donor or fluoride acceptor. It can donate fluoride ions or it can accept fluoride ions. It depends upon the nature of reactant. Xenon difluoride when reacts with phosphorus pentafluoride or antimony, or you can in place of phosphorus you can take also antimony pentafluoride. You can take also antimony pentafluoride, phosphorus pentafluoride. It produce here acts as a fluoride donor. It provides fluoride ions. So F minus will be accepted by F minus. That's why PF6 minus. So PF5 accept one F minus. So it will produce PF6 minus. Then xenon difluoride become XCF plus. So it produce a ionic species, ionic compound. This fluorides of xenon when combines with PF5 produce a ionic compound due to transfer of F minus from one fluorides to other fluorides. Because phosphorus has a vacant d orbital, it accepts F minus. It can accept F minus, that's why product is PF6 minus. Similarly, you see the difference here. This xenon hexafluoride with NF, this xenon hexafluoride can accept F minus. So when it accept, here it is a acceptor, but first one is a donor. When it accepts F minus, it produces XeF minus, XeF7 minus. That's why then sodium plus will be sodium fluoride, potassium fluoride, that means alkyl metal fluorides. Remember, alkyl metal fluorides when reacts with the fluorides of xenon always acts as a fluoride donors. Then automatically fluorides of xenon will be acceptor. So this is the difference between the fluorides of xenon forming the ionic compound acts as a fluoride donor or fluoride acceptor. So these are the very important preparation of what preparation, we can say the properties of fluorides and oxides of xenon. Then what are the important uses of noble gases? Because noble gas is very important for our day-to-day life also. We are using so many purposes. For example, helium is used in filling balloons. Why we are filling balloons, filling helium in balloons? Because it is non-inflammable. It does not catch fire. So non-inflammable, then it's lighter. That's why it is lifting capacity is more. That's why it is used in filling balloons. You compare to hydrogen can be combustible, but helium is non-combustible, non-inflammable and lighter. That's why it is used in filling balloons. This is very important for filling balloons. Then another use that liquid helium is used as a cryogenic agent for surgery. Different instrument surgery, liquid helium used as a cryogenic agent during surgery. Then neon is used in fluorescent bulb. For color light, neon is used. You know neon lamp, also neon light used in your rocket and aeroplane. That red light is produced from aeroplane, that is also fluorescent light. Neon is used in fluorescent bulb. Argon is used in filling electric bulb. Electric bulb also used in argon because argon is inert. So for illumination, for better illumination, we can use the inert gases like nitrogen, argon, neon gas can be used for filling the bulbs because its illumination is more. Then another important use also you can recall, you have read in a solution chapter that what helium and neon mixture, helium and oxygen mixture used by scuba diver. Scuba diver generally use helium oxygen mixture because if nitrogen content will be more, if percent of nitrogen more, it will cause bent disease. That's why to prevent bent disease, helium mixture is used. Helium and oxygen can be used by the scuba diver. This is also important use of noble gases. Then very important part is that we will discuss now, that is structure of noble gas compound. It is asked in your examination. Question is asking that what are the structure, what are the hybridization of noble gases, compounds of noble gases. You see xenon difluoride. If you see the xenon difluoride, you see, we know xenon has 8 electron in its outermost shell. If you see that xenon has 8 electrons outermost shell. So out of 8, 2 fluorine combine. Then remaining how many? Remaining 3. The 3 pairs. These 3 pairs These three pairs becomes arranged around the two fluorine atoms around the xenon and forming linear structure. So structure is linear. Linear structure. And what is the hybridization? What is the hybridization? Here you can say you just use the VSEP pair theory. See, the system is AB2, then how many lone pair? 3 lone pair, AB2L3, that is your hybridization is how much? B2L3 means 5, that is sp3d. So xenon difluoride, that it has sp3d hybridization, linear shape, and structure is like this. Then come to xenon tetrafluoride. Xenon tetrafluoride, just like you can say which type of structure, that out of 8, 4 electrons share with the 4 electrons of xenon share with 4 fluorine atoms, remaining 2 lone pair, one below, one above, like this. So this shape is square planar. This is square planar shape, and this is AB4, just like this, AB4L2. AB4L2 is what type of hybridization? sp3d2, because 6. AB4L2 means 6. 6 means sp3d2. Similarly, this is 6 xenon hexafluoride. It will be like this. Then remaining above and below, remaining 1 lone pair. So it is distorted octahedral. And the system is AB6L and hybridization is sp3. Total is 1, 2, 3, 4, 5, 6 and 1 lone pair 7. sp3d3. So it is distorted octahedral. Remaining xenon trioxide, its structure is very easy. Like this you can draw 3 oxygen, like this. No lone pair remain. One lone pair will remain because it has 8 electrons. So 6 electrons shared by 3 oxygen. So it is AB3L. Then shape is pyramidal shape, and it is sp3 hybridization. Because AB3L, that is sp3. Then remaining xenon oxyfluoride. So same structure, xenon, then 2 fluorine will be like this, you can say, then 1 oxygen like this, then remaining 1 lone pair. 1 lone pair you can say like this. So it is what type of shape? T shape. It is T shape. Just like T shape and having 1 lone pair. That's why it is how many lone pair? 2 lone pair, not 1 lone pair. It is 2 lone pair. If count, it will be 2 lone pair because 2 electron with the oxygen, then fluorine 2 electron, 4, remaining 4. That is 8. So it is Ab3L2. System is A. It is just like Ab3L2. Ab3L2. T shape. Always Ab3L2 is T shape according to VSEP pair theory. Then remaining xenon, which one? Xenon oxytetrafluoride. Oxytetrafluoride means 4 oxygen. 4 oxygen will be like this. Okay. Then 1 oxygen will be like this. So it has how many lone pair? 1 lone pair. Only 1 lone pair. So the system is AB5L. AB5L. Here I have not written the hybridization. Here is our AB3, say B3L2 hybridization will be B3L2 means 5, so sp3d. Here it will be AB5L means 6, A will not be considered, only B and L. So B5L means 6, 6 means sp3 hybridization. sp3d2 hybridization, sp3d2 hybridization, and AB5L molecule as per the VSEPR theory is what? Square pyramidal. Square pyramidal. This concept already we have read in class 11th in VSEPR theory. So we have applied VSEPR theory. How many bonded atom, how many lone pair available in the around central atom. Then we can know the, for example, you see XCF2, FB2, and the remaining 3 lone pair, FB2L3 always linear, and FB2L3 means 3. AB2L3 means here total B and L2 how much? 5. 5 means sp3d. Here AB4L2 total is 6 means sp3d2, like this. This concept already you have read in 11th. So this is regarding the structure of noble gas compound. This type question also asked in your examination, your in different competitive examination. So this is regarding your preparation and properties of noble gases, and the some uses of noble gases, and the structure of compounds of especially oxides and fluorides of xenon. So this is regarding the preparation and properties and uses of noble gas and its compound. Okay.